Okay, first of all, what is IRR? So IRR is basically the internal rate of return and is widely used in a financial metric in a capital budgeting to estimate the profitability of a potential investment. So IRR is also known as a yield rate, which is the rate of interest at which present value of a contribution from the investment is equal to the present value of return into the investment. In another way, in a simpler terms, IRR is the implied annual rate of return that an investment is expected to generate. And the value if I for which NPVI is equal to 0.
Okay everyone, my name is Matan Syamila Azman, I'm engineer number 214-255. So now I will talk about TWRR, time weighted rate of return. Basically, TWRR is a measure the compound of rate that grow in a portfolio that eliminate the impact of external cash flow like deposit and withdrawal. So in simple word, TWRR tell you how well your money would have grown if you never added or withdraw anything, just left it to perform based on the fund or manager skill. So here I put the formula that related to the TWRR. Basically, P balance before the cash flow, C the cash flow, and JK the return for that sub period.
Hi, my name is Nafaiza Hani binti Zaidi. I will explain the task 1, problem 1, 2, and 3. So the problem 1, find the IRR of the transaction that has the following net cash flow. So the first method is by using the Excel. So I just copy the table, which is time from 0 until 2, and the net cash flow is negative 1,450 and 630. So how to calculate the IRR, which is equal IRR, open bracket, I just drag the table from the C7 until the C9 and close bracket, and the answer is 5%. So the second method is I calculate manually. The first step is I set the NPVI is equal to 0, which is negative 1000 plus 450V plus 630V square is equal to 0. And I solve this by using the quadratic formula, which is negative B plus minus square root of B square minus 4AC over 2A. And I just substitute the value and I get a 2V, which is V1 is 0.952381 and for the V2 is negative 1.666667. So since V is actually 1 plus I, power of negative 1, is same with the 1 over 1 plus I. So we can calculate the value of I, which is for the first one, for the V1 we get the I is 5%, and for the V2 we get the I is negative 160%, which is the negative value of IRR. So the conclusion is, thus the internal rate of return IRR that make the present value of the cash flow is equal to 0 is 5%. So we choose the 5% instead of we choose the negative one. So this answer is same with the calculate by using the Excel, which is the answer is 5%. So that's all for the task 1. So let's move on to the problem 2. Problem 2, find the IRR of the transaction that has the following net cash flow. So same like previous one, the first method is we use the Excel and we get the IRR, which is 31%. And the second method is by calculating manually. First step is set NPVI equal to 0 and solve the quadratic equation by using the quadratic formula, and we got a 2V, which is V1 is 0.763086 and V2 is negative 1.638086. So we can calculate I. So for V1 we get I is 31.05%, while for the V2 we get I is negative 161.05%, which is the negative value of IRR. So the conclusion is, thus the IRR that makes the present value of the cash flow equal to the 0 is 31.05. We choose the positive one, which is 31.05. Same answer like by using the Excel, but have a slightly different due to the decimal, which is 0.05%. So that's all for the problem 2. So next, let's move on to the problem 3. A project requires an initial investment of the 2,000 ringgit. It is expected to get a return of the 6,500 in year 1 with the contribution of the 1,000 in the same year and another return of the 6,000 in the year 2. Find the IRR of the project. So I built the table, time, contribution, return and net cash flow. Net cash flow for the 0 time is negative 12,000 and time 1 5,050 ringgit because 6,500 minus with the 1,000. And for the time 2 I get 6,000. So the first method is by using the Excel like the previous one. So I get the IRR value, which is negative 3%. So the second method is I calculate manually, which is I set the NPVI is equal to the 0 and I solve the quadratic equation using the quadratic formula, and I got the 2V, which is V1 1.028297 and V2, which is negative 1.944964. So I calculate for the I V1, which is I get a negative 2.75%, and while for the V2 I get I, which is negative 151.41%. So thus the IRR that makes the present value of the cash flow equal to 0 is negative 2.75%. I choose the greater negative. I choose the negative 2.75. So when I compare negative 2.75 with the Excel one, when I round off, it's same answer, which is negative 3%. So that's all for the problem 3.
Okay, now I will explain three problems in task 2. Okay, in problem 1, we are given a fund with an initial balance of 5,000 ringgit. Several transactions occur throughout the year. A drop in value, a deposit, a withdrawal, and finally a year-end balance of 5,500 ringgit. Our goal is to find TWRR. Okay, we split the year into segments based on transaction date. For each sub-period, we calculate the return J using the formula. So there I state the formula. Then we compute TWRR by compounding TWRR equal to 1 plus J1, 1 plus J2 times 1 plus J3 minus 1. Then we substitute the J into that formula. Then we get TWRR is 4.13%. So TWRR for the problem is 4.13%. Then for problem 2, we are given fund balance and transaction for the year 2022, 2020, 2023. Again, we calculate TWR by breaking into yearly interval and using the same formula. Okay, using the formula for each year return J, we get J1 equal to 0.30, J2 0.0417, and J3 negative 0.1667. Now we compute in TWRR formula, and we get 13.09%. So the TWRR for the problem 2 is 13.09%. Now let's move on to problem 3. Here we given beginning balance of 2,000 ringgit and a withdrawal of 100 on May 1st. The year-end balance is 2,250 ringgit. We are told that the time rate return TWRR is 50%, and we need to find the balance in the fund on 1st May. So we assume the value of the fund on 1st is X. Then the TWRR is calculated by multiplying the sub-period return. So using the return formula, we get J1 and J2. Then we substitute it into TWRR formula and equal it with 0.15. Then we did expanding and simplifying. We get X equal to 4,600. So the balance in the fund on May 1st was RM 4,600.
Hi, I'm Farisha Usnam. My metric number is 215191. I'll present task 3, which is the case study. You are part of a startup team running a tab-based retail platform. In 2024, you launched a new feature with an initial investment of 15,000. As you can see in the table, in the cash flow, 15,000 become negative because we invest in the business. On March 1, you injected another 5,000 to support marketing. Another cash flow, so same, negative 5,000. On July 1, an investor gave you 3,000 to support your business. When we get the 3,000, that's when it's positive 3,000. So on December 31, the total revenue reached 26,000. Okay, so problem 1, compute the IRR for the investment. IRR is internal rate of return when the NPV equal to 0. So from the problem, we get the equation as written. Okay, so for the first step, we use linear interpolation. So we assume I equal to 15%, and we find the value of V and we substitute in the formula NPV. So we get 110.27, which is more than 0. So the next step, I assume I equal to 16, and we do the same step, and we get negative 1,000.84, which is less than 0. So as we can see, we want to find when NPV equal to 0. So the value of I must between the 15% and 60%. And for the last step, I use linear interpolation, and I get I equal to 51%, same as in the Excel. For the Excel, I use SIRR function. Okay, next we go to the problem 2, compute the TWRR for the investment, time weighted rate of return. So this is the timeline. There is 3 periods. For period 1, before 5,000 ringgit Malaysia added. For period 2, before 30,000 ringgit Malaysia added. And the last one is period 3, ending with 26,000 ringgit Malaysia. So this is the table, and we calculate the value of J. The formula of J is end value minus start value over start value. From the all value of J for all period 1, 2, and 3, we calculate the TWRR using the formula as stated, and we get 0.1304 or 13.04%. That's how we get the TWRR. Next, for problem 3, we compare and interpret the result. So IRR we get 15.1%, and TWRR we get 13.04%. So there is difference. For IRR, high return indicating strong overall project profitability, including the timing and size of cash flow. Meanwhile, TWRR has a moderate return, reflecting the actual investment performance, excluding effect of cash flow timing. That is the difference. Okay, so for the challenges, I think the first one is we have to master the technique of using Excel functions, so that we can check the answer with the answer that we do manually. And the second one is how well we extract the accurate information from the situation, as especially in the case study and real life study. When we extract the wrong answer, the wrong information, that will affect our result. Next, for the insights, we have understand that IRR helps evaluate project profitability including timing. Meanwhile, TWRR focus on actual investment performance regardless of cash flow timing. So overall, what we learn is we gain a better understanding of financial return concept or the term and how to apply them in real world business scenarios.